All right, ladies and gentlemen, welcome back to this Athenian Stranger tutorial video where today we are going to begin a new unit on congruent triangles. This is Unit 4, and we have before us a notes packet, which we are going to dive into directly. The first page of the notes packet is on classifying triangles. So, I had a student say, I thought geometry was going to be more about learning the things about shapes, and, I took that to heart. I agree. It's something that we'll learn more about in this section. So, to that student and any other student who thought geometry was supposed to be about shapes, know that I agree with you, and I hope this section kind of meets your needs. Okay, so we have to learn how to classify triangles given their angles. The first triangle we'll look at here is a triangle that has three acute angles. Those are three angles, all of which are less than 90 degrees. And we call a triangle with three acute angles acute. And we call a pen with no ink empty. So this is an acute triangle. And here we're looking at a triangle, and two of the angles are acute, and one of the angles is obtuse. Now remember, obtuse means that the angle is greater than 90 degrees, and you can see here that this angle here is greater than 90 degrees, so we call this an obtuse triangle. Next up, we have a triangle with two acute angles and one right angle. And a right angle is an angle that is exactly 90 degrees, and we call this a right triangle. And now we have a triangle that has three identical angles. They're all congruent, and incidentally, they're all acute. And we call this an equiangular triangle. We don't know anything about its sides yet, but its angles are all acute. Its angles are all congruent, rather, so we call it equiangular or equiangular. And here's how you spell that: E Q U I A N G U L A R. So an equiangular triangle. Okay, so now we're going to take a look at this diagram right here and classify the triangles that we find within it. So without looking at this mess right here, we can kind of classify these triangles one at a time. This triangle here is equiangular, okay? This triangle right here. This triangle right here appears to be an obtuse triangle. Here I see a triangle that appears to be acute, and here's another triangle that appears to be obtuse. So let's see if we were right. So triangle CDE, CDE. Oh, I see. This bigger triangle here has a right angle at angle E, so this would be a right triangle. Triangle CDE is a right triangle. Triangle BCE, BCE is an obtuse triangle. Triangle ABE ABE. That is an equiangular triangle. And that's EQUIANGULAR, equiangular triangle. Triangle BDE, BDE. So there's some triangles here that we didn't see right off the bat. BDE, that looks like an obtuse triangle. Yeah, it is an obtuse triangle. And triangle CFE, CFE, that is an acute triangle. So good, our intuition was spot on. But my spelling is not spot on. Actu. I mean acute. Let's see if I can erase that. Okay, so now we've classified triangles by their angles. Let's now look not at the angles, but at the sides. So we're given three triangles here. In the first triangle, these little hash marks or dash marks on the sides indicate that they are congruent. So this means that all three sides are congruent. So this triangle is called an equilateral triangle. So up here, we had a triangle called an equiangular triangle because all the angles were congruent. This is called an equilateral triangle because all the legs or all the sides are congruent. EQUI, lateral, LATERAL, equilateral triangle. Okay, now here's a triangle that has two congruent sides. So this side and this side are congruent, and this is called an isosceles triangle. And that is spelled ISOSCELES triangle, isosceles triangle. And finally, we have a triangle with no congruent sides. And all of these types of triangles are called scalene, SCALENE, scalene triangle. Okay, so classified by sides, we have an equilateral, an isosceles, and a scalene triangle. Okay, so just like above, where we looked at a diagram and then classified the triangle, we are now going to look at a diagram and classify the triangle again, this time by its sides. Okay, so once again, if we just look at this picture, we can do a couple of things. This triangle KJN or NJK or however you want to name it, this big triangle right here, this has legs that are all the same length, and so this would be an equilateral triangle. Here, this triangle here, this guy right in here, KLN, this has two sides. See these two dash marks? They indicate that these two sides are the same. So this would be a little isosceles triangle right here. And here in LNM, we don't have any indication that any of the sides are the same, so that would be a scalene triangle. And further, there are bigger triangles here that we could identify, such as KNM, where we don't have any sides that are the same. And finally, the large triangle KJM is another triangle that would be a scalene. So we'll see what they ask us for. triangle JKM. JKM, the big triangle, is in fact scalene because none of the sides are the same length. Scalene. S-C-A-L-E-N-E. Scalene. Triangle KLN. KLN. This little guy right here, remember we saw two sides were the same length, so this would be an isosceles triangle. I-S-O-S-C-E-L-E-S. Isosceles triangle. And now triangle JKN. Triangle JKN has three equal length sides, so we call that equilateral. EQUILATERAL. Equilateral triangle. Okay? So now that we've classified triangles by only their angles and then only by their sides, let's bring that together and classify triangles by both their angles and their sides. Okay, so it might be difficult to see these angles on the monitor, but you have a physical copy in front of you. Take a look at these for just a moment, and then we'll come back together. Okay, so the way that I'd like to do this is I'd like to look at the triangles first by their angles and then by their sides. And we're going to write two different things down. And I'll do that in two different colors. I guess I'll use blue and I like to use red. Blue and red. Okay, we'll see if that red pen has any ink in it. So we'll do the angles in red, and then we'll do the sides in blue. Okay, so the angles will be in red, and the sides will be in blue. So on number 9, we can identify this from an angular perspective as being a right triangle because it has a right angle. So this is a right triangle. And if we look at its sides, it has two sides that are of equal length. And any triangle with two sides of equal length is called isosceles. So this is a full identification here by angles and sides, a right isosceles triangle. And remember, isosceles is spelled I-S-O-S-C-E-L-E-S. So this is a right isosceles triangle. Okay, and number 10, we have one angle that we're given that is over 90 degrees. This says 114 degrees. That is an obtuse angle. So this is an obtuse triangle. From an angular perspective, and from a lateral perspective, or from the perspective of looking at the sides, we're not given any information about the length of the sides. So we have to assume that none of them are of equal length. So that is called scalene. So this is an obtuse scalene triangle. Okay, very good. Now, this number 11 is a little bit more interesting because instead of the symbols to indicate equiangular and equilateral, we're given numbers. And if we look at the angle measurements, this one's 60, 60, and 60. and those are all equiangular. Okay, so they would all have these little angle symbols in common. And so we would call this equiangular, Equiangular, equiangular. And notice also that the length of the sides are the same, 7, 7, and 7. So they would have these little dash marks. And those are indicative of an equilateral triangle. So we have something that's both equiangular and equilateral. Equiangular and equilateral. Okay, on to number 12. Notice here that we're given no indication that any of these angles are the same. But it's plain from the picture that none of them are obtuse. Can you see that? That none of them appear to be greater than 90 degrees. And so we can classify this as the opposite of an obtuse triangle, which would be an acute triangle. This is an acute triangle, and now we have to look at it laterally, or by the length of the legs of the triangle. And we see that here this is 15, 20, and 18. None of those are the same. So we classify a triangle with no congruent sides to be scalene. So this is an acute scalene triangle. Okay, in number 13, we are told that we have a right angle indicated by this symbol right here. So this is a right triangle. From an angular perspective, from a lateral perspective, or from the perspective of the length of the sides, we're given no information. So this is a key point. In the absence of information, you have to assume that none of the lengths are the same. This triangle it gives you that, right? It appears that none of the lengths are the same, but sometimes it doesn't look that way. And you just have to go on the fact that you don't have any information, so you have to indicate that it's scalene. Remember, scalene means there are no congruent sides. Okay, number 14. Right away, we're focused on the angular part, and we see that it's 97 degrees, and 97 degrees is greater than 90 degrees, so this is an obtuse angle. So this is an obtuse triangle from an angular perspective. From a lateral perspective, I'm given two of the sides. I'm given that this side is 5 feet, and this other side is also 5 feet. So if two sides are the same, it is an isosceles triangle. So this is an obtuse isosceles. ISOSCELES. Obtuse isosceles. So we'll take a minute here just to let you get all that written down. Okay, moving on. So this is the back of that page we were just on. Oh boy. So now we have to take some information and about bisectors and midpoints, and then start classifying the triangle. This is where it gets interesting. Oh, I'm excited. So let's see what this is all about and see if we can make heads or tails of it. So first, let's figure out what triangle we're talking about here. Triangle UQR. And I'm going to help us out. I'm going to attempt to help us out by focusing in on that triangle here. See if this is helpful or a total waste of time. UQR, where is that? UQR. All right, so we're told that PR, where's PR? PR is bisecting angle SRT. SRT. Okay, and we're focused on UQR. UQR. So I'm not sure that that's affected. So looking at triangle UQR, it kind of looks like this. Okay? So here's the triangle, UQR. Let's just do exactly what we were doing on the previous page. First, we'll classify it by its angle. So here I've got an obtuse angle here at 120. This is obtuse. So from an angular perspective, it's obtuse. And then from a lateral perspective, I have two sides that are the same length, which means it's an isosceles triangle. ISOSCELES. Okay, so we have an obtuse isosceles triangle. So UQR is an obtuse isosceles triangle. Okay, so the next one is triangle RST. RST. See, I think it is important that we transfer these images a little bit because there's a lot of confusing information. So here we're given this triangle RST, and it kind of looks like this. Okay, and we're told that this line PR is bisecting it, so kind of we're not so interested in this, but there's this line bisecting it, and this angle right here is given as 30 degrees. Okay, this side is given as 16 meters. This angle here is given as 60 degrees. And this side is given as 8 meters. We are told that U is the midpoint of RT, and that's relevant, yep, because that means there's this dashed line here that is neatly dividing this triangle in two. So let's see what we can discover about this triangle, which is SRT. Okay, so we're going to focus here on this triangle. So this side, let's focus on angles first. So this angle is 60 degrees. Okay, so this angle here, well, we'll see about that. The way that we're going to go about this is realize that this dashed line is bisecting this triangle completely in half. So if this angle is 30 degrees, then this angle right here must also be 30 degrees. So if you take these two angles together, they're 60 degrees. Okay, so this big angle right here is 60 degrees. Right? Now, if this angle is 60 degrees and this angle is 60 degrees, then you have a situation where you have two angles that add up to 120 degrees, this one and this one. So we're not told what this angle is, right? What is it? Well, if we subtract 120 from 180, we get 60. So here we have 60 degrees. So from an angular perspective, we have 60, 60, and 60. So this triangle is equiangular. What about lateral, or the length of the legs? Well, we need this piece of information about the midpoint. We were told that this point right here, which they called U, is the midpoint of R and T. So if that's the midpoint, that means that RU is equal to UT. Well, RU is 8 meters. So that means that UT is 8 meters. Taken together, the full length of RT is the sum of RU plus UT, which is 8 plus 8, which is 16 meters. Okay? Further, so this side is 16 meters, this side is 16 meters. And finally, we look here and we see that this point here, which is SQ, is 8 meters. And we're told that this line that contains segment QR, this line PR, is bisecting SRT. Okay, so it's bisecting this. By bisecting it, it means that this part here is equal to this part here. So this is also 8 meters. And so the full length of ST is also 16 meters. So notice that from a lateral perspective, we have 16, 16, and 16. So this is equilateral as well. So it's equiangular and it's equilateral. Equiangular, EQUI, ANG, ULAR, and equilateral, EQUI, LATERAL. So equiangular and equilateral. And that's triangle RST. Now triangle SRQ. SRQ. Okay, I don't think we need to draw this one because it's all contained right here. Let's see what we got. We have, from an angular perspective, angle Q is a right angle. So from an angular perspective, this is a right triangle. And from a lateral perspective, this side is 8 and this side is 16, and we don't know what this length is here, okay? But it's not 8 or 16 because these little hash marks aren't helping us. They're not telling us that it's the same. So it's when we don't have any sides that are the same length, we call that a scalene triangle. So it's a right scalene triangle. Okay, so SRQ is right scalene. How about PRT? PRT. Now this is one where I feel like we need to draw it. Okay, this is P, R, T. And we got to label some stuff here. This is 16 meters. We already established that RT was 16 meters. We have no idea what this length is on top. This is just unknown. And we already established that this angle right here is 30 degrees. Okay. Down here it tells us that this ST, SRT is being bisected here. So this angle right here is 60 degrees. Okay. All right, so this is the information that we need. This is given to us as 8 meters. I don't know if we need that information. Okay? So let's look at it from an angular perspective. If this dashed line is bisecting this angle, right? This is QT, right? And we were told in the problem that PR is bisecting SRT and that U is the midpoint of RT. We established that segment ST is cleanly bisecting this angle PRT. So if this is 60 degrees, this is 60 degrees. Okay, and if this is 60 degrees and this is 60 degrees, then the whole angle here, angle T, is 120 degrees. And because 120 degrees is greater than 90 degrees, that's an obtuse angle. And the presence of that obtuse angle means that this is an obtuse triangle. Okay. Now, that's from an angular perspective. How about from a lateral perspective or from a length perspective of the sides? Well, we have no idea what segment PR is in terms of length. But we know that segment PT is 16 meters, and we know that segment RT is 16 meters. So these sides are equilateral. These two sides are. And so because those two sides are equilateral, they represent two sides of the same triangle. The whole triangle is classified as isosceles. ISOSCELES. So this is an obtuse isosceles triangle. Triangle PRT. Obtuse isosceles. Okay, now triangle TQU. TQU. This is one, the whole thing is contained there on the picture. It's easy to look at. Here, we're looking at this guy right in here. TQU, this guy. Okay, so let's look at it from an angular perspective. Well, we actually know some information about this angle right here. This angle U, this angle right here. This one I'm talking about. So we have adjacent angles right here, and they form a linear pair. Right now, because they form a linear pair, that means that they have to add up to 180. Well, this angle here is 120, so this angle here must be 180 minus 120, which means that this angle is 60. Okay, so we know that this angle right here is 60. Angle QUT is 60. So that means that we have two angles that are the same. Can we say anything about this angle right here? Okay, well, let's see if we can say anything about it. We can, because we know that the sum of the interior angles of a triangle have to add up to 180. So we have two of those angles. We have this one and this one. This one's 60 and this one's 60. So all we have to do is do 180 minus 60 plus 60, which is 120. 180 minus 120 means that this angle is also 60. Okay, so 60, 60, 60, we call that equiangular. So this is an equiangular triangle. Remember, that's from an angular perspective, equiangular. How about from a lateral perspective? What can we deduce? Well, we have to follow a kind of chain of reasoning to deduce the following thing. Notice here for segment RU, we're told it's 8 meters, and then we're told that this segment QU is also the same. With that little hash mark, it means that this is also 8 meters. Okay, so we know that this is 8 meters. We're given that segment QT is 8 meters. So we have here this being 8 meters and this being 8 meters. So you would think maybe it's isosceles, but we already established that since QU is the midpoint here, where U is the midpoint of RT, that because this is the midpoint, that RU is equal to UT, so this is also 8 meters. So notice now that we have all sides are the same length. So this is an equiangular and equilateral triangle. Equiangular and equilateral. Equilateral is EQUILATERAL. So equiangular and equilateral. And finally, triangle PQT. 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 Okay. So what information do we have about this triangle? Well, again, following a chain of reasoning, and this is what's wonderful about geometry. You have to kind of visually understand. Because this angle SQR is a right angle right here, then that means that angle SQP is also a right angle, which means that because these two are right angles, this angle here, PQT, is also a right angle. Okay, so this is a right angle right here, 90 degrees, PQT. We have the presence of a right angle, so because we have the presence of a right angle, we call this a right triangle. This is triangle PQT. This is a right triangle. Okay, now that's from an angular perspective. What about from a lateral perspective, or from the perspective of the side lengths? Well, remember, we have no information about side length PQ. We don't know anything about it. We have length PT is 16, and we have QT is 8. So we have different side lengths, none of which are the same. Otherwise, there'd be a dash. So we have no side lengths that are the same. So because none of the lengths are the same, it's called a scalene. So this is right scalene, SCALENE. Okay. Now, we are going to pause there because the next part of this requires us to use the distance formula in order to figure out the measures of a triangle and then classify it according to those measures. All right, so that's a different story, and that's what we'll cover starting tomorrow. This whole lesson here took us 39 minutes. We will call 40 minutes. Okay, this took 40 minutes to do this today. So we'll hit this classifying triangles tomorrow. All right. Okay, so I hope you found this video helpful. If we're sitting here watching it in class, this is irrelevant, but if you're watching it at home, please like, subscribe, and hit the notification bell. Leave a comment. You'll find links in the description to other videos in this channel, and make sure you keep checking back for new videos to help you with math tutorials. Thank you.